In this video, we will graph sine and cosine using period, midline, amplitude, and phase shift. Number 7, the period. We can calculate the period by doing 2 pi divided by the b value. The b value is this number in front of the x. So that means we have 2 pi, well, let me just write it this way. So we have 2 pi divided by b, if you will. So in this case, it'll be easier for me to write it this way. 2 pi divided by 1/2. And of course, we don't need a calculator for this because this will be 2 pi times 2 because you multiply by the reciprocal. So the period is going to be 4 pi. Alright, so let's put 4 pi at the end like this. Alright, so in the middle we will have 2 pi. Halfway to that will be 1 pi. And halfway between these will be 3 pi. Alright, this one is always 3 of these. Now, the equation of the midline is going to be determined by this vertical shift of -2. So that means y equals -2 will be my new midline. So let's go ahead and draw. So there's our new midline. The amplitude is going to come from this number right here. Amplitude is always positive, even when this is a negative a value, but it's positive anyway, so the amplitude is 3. Let's pause there. Let's deal with the phase shift separately. There is a phase shift, and it's going to have to do with this pi over 3. But before we graph and do anything with the phase shift, let's go ahead and use these values that we already have to graph a skeleton version pre-phase shift. So I always do that in light green, which is not super easy to see, but that's okay because it's just the skeleton. I don't want you to see it that well. So here's what we do. We are going to pay attention to the fact that this is the sine function, and in terms of the 5 key points that we're going to plot first for this period, the sine function always starts off on the midline, and when it's a positive sine function, it always goes up and then down and back. So we're going to do this pattern, but being careful to use the amplitude. So whatever the amplitude is, we're going to go up that much, and we're going to go down the amplitude. Okay, so like I said, for the sine function, we're always going to start at the midline. So we're going to put our first point there. Now the amplitude is 3, so that means as I move to this first position, I'm going to go up 3 from the midline. So that's going to be right here, okay? And then I return to the midline at the next position, and then I go below the midline, alright? And again, I'm using the amplitude, so I go down 3. And then I go back to the midline again. Alright, so this is the skeleton of one period of this function. So now it's time to do not connect these dots. Just leave that as the 5-point skeleton. The phase shift will determine how far to the left or right we're going to shift these 5 points, because that's all that's left. The way phase shift works is focus your eyes on the part that's inside the parentheses here. Alright, so I have 1/2 x plus pi over 3. Okay, so I need to factor out this coefficient. So I need to bring this 1/2 outside of parentheses to see what the phase shift truly is. To know what goes inside, you divide. So I am dividing by 1/2 here and here. So of course these will cancel out. That tells me I'm just going to have x right here, of course. But here's where the phase shift comes in, and it's going to come from this right here, pi over 3 divided by 1/2. Now if you want to do that by hand, then you're going to go, okay, pi over 3 divided by 1/2 is equal to pi over 3 times 2. Okay, multiply by the reciprocal. So that's going to be 2 pi over 3 is going to be my phase shift. All right, or you could just put it in your calculator. So the phase shift is 2 pi, let me leave space. Yeah, the phase shift is 2 pi over 3. But it's always going to be the opposite of this, all right, the opposite of what you see. So the phase shift is actually going to be negative 2 pi over 3. And go ahead and include the word left. Okay, again, plus, normally things that are positive would be to the right. But when you're doing horizontal translations, which is what this phase shift is, it's always the opposite of this. So positive actually moves you to the left, so we call it a negative phase shift. Okay, so now we found what the phase shift is. What do I do with it? Again, this phase shift is telling me to take each of these 5 skeleton points and shift them to the left by this amount, all right, 2/3 pi to the left. It's just a matter of, on this scale, how much is that? You know, is that 1 square, 2 squares? Is it less than a square? Well, to help us figure out how big this is on this graph, it's going to help to do 2 things. For one thing, it will help if we look at this in terms of a decimal. Now, do not turn the pi into a decimal. Okay, keep the pi. But look at the rest of it. Look at the 2/3. All right, 2/3. Okay, as a decimal is 0.6 repeating. So it's approximately 0.7 if we looked at just one decimal place. Okay, so that makes this negative 0.7 pi. 0.7. Okay, now remember, this is pi right here. This would be 0.5 pi. You know, pi over 2. This would be half of a pi. So that means 0.7 pi is more than 1 square, all right, because each square is 0.5 pi. So we're going to the left, though, so that means we're going to go to the left more than 1 square. So going to the left to here would be negative 0.5, so negative 0.7 would be like somewhere around in here. Okay, more than a square. So I'm just going to take each one of these and do that and move them negative 0.7, all right, negative bigger than 1 square. So that would be like here. This one would land here. This point would land here. And this point would land here. Okay? So that's it. This is one period of this graph. So I'm going to go ahead and sketch that now. Okay, so that is one period of this graph. Now I want to draw more until I run out of space. Okay, I think I'll do the rest in green. Change my mind. I'm doing purple. Okay, so what would happen is this. I think it might be easiest to extend the skeleton first and then continue to shift those points. So looking back to our green skeleton, if I extended that skeleton, and I'm changing colors so you can always see the original 5 points, but going from left to right, I'm going up and then down and then up. Alright, so continuing from here, in my next position, I'm going to be up 3 again, okay, from the midline. And then in my next position, I'll be back down to the midline. So I would have these additional 2 points pre-phase shift. Now if I continued the skeleton to the left, alright, I went up and then now I'm coming down, so I'd be here, and then I'd come back up again, so I'd be here. So these gray points are like extended skeleton. Okay, so now I can continue with by shifting these points as well. So remember, we were shifting each point to the left more than one square. So this point is now going to come more than one square to the left. Alright, this one is off the graph, so I won't do that one. Okay, but so that means I will have this, though. I can just go ahead and add this on right now. And coming this way, this point will move more than one square to the left, and this point would move more than one square to the left. Alright, so I can continue the graph this way. Okay, so you can see the pink part here is our original 1 period, but I would like you to graph as much as will fit. So I got this little extra part on the end. That way you're showing me that you understand how this is really working. Okay, even though that was only one problem, I feel like maybe I should stop. No, I'll go ahead and do number 8 as well. Let me see if I can do this one a little faster. Okay, the period. Remember that the period is 2 pi over b. Okay, in this case, the b value, there is no b value. I mean, I could call it a 1, alright? But that means the period is just 2 pi. Alright, so the period is going to be 2 pi, a classic. So that means we'll just put 2 pi right here. You know, did I ever label the y-axis on this? You know, shame on me for not labeling the y-axis. We were just using the normal units, so I got a little lax. But you should label this 1, 2, 3, 4, -1, -2, -3, -4. Always label your y-axis as well, because sometimes we change this, so I don't want to assume anything. So label your x-axis and your y-axis. Okay, anyway, the period is 2 pi. That means here in the middle I will have pi. Right here I'll have pi over 2. And right here I'll have 3 pi over 2. This third position is always 3 times the first position. So there you go. The equation of the midline comes from a vertical shift being added or subtracted on the end, but there is nothing. So that means y equals 0. The x-axis continues to be the midline for this problem. Okay, great. What about the amplitude? Well, that's going to be 3. Alright, if this were negative, the amplitude is always positive, but doesn't matter, it's 3 right now. There is a phase shift, and because there's no b value, this is the phase shift. Okay, so I might as well just put it down. So it's pi over 3. It's the opposite. So this is negative, that's why I put positive, and I'm going to put the word right. Okay, so when it's negative, you go to the right. If it were positive, we would go to the left. Okay, so let's do this graph now. So I always like to start with a 5-point skeleton without the phase shift. So this is a cosine function. Remember that cosine starts off above or below the midline at the amplitude. So this is positive, so cosine will start off, in this case, 3 above the midline. So cosine is going to start off right here. Alright, and then it goes to the midline, below, back to the midline, above. So it's going to go to the midline, below, back to the midline, above. Okay, do not connect these points. This is just the skeleton. Now comes the phase shift. We need to move each of these points pi over 3 to the right. So how much is that? How many, is that more than a square? Is it less than a square? Well, it helps to consider what this next value is in between. So if this is pi over 2, then right here would be pi over 4. So you can bet that pi over 3 is going to be between pi over 2 and pi over 4. All right, it's going to be in between there. So that means as we move to the right, pi over 3 is going to be more than 1 square to the right. So I'm going to move more than 1 square to the right. Okay, each one of these, more than 1 square to the right. More than 1 square to the right. More than 1 square to the right. And more than 1 square to the right. So this will be a pretty good approximation for my 1 period of this graph. Okay, so there's 1 period of this graph. So we'll start with that. But I would like you to extend this graph and graph as much as you can fit on this graph paper. So the graph would continue. Let's extend the skeleton first. So if I continue the skeleton, here I'm at a high point. I'm going to come back down to the midline, and then I would go below it. Same thing would happen over here. I would wind up coming back down to the midline, and I would pass right through it, and I end up here. So that's what this would have looked like if I continued my skeleton. So remember, we were moving pi over 3 to the right, and in this case, pi over 3 was more than 1 square to the right. So I'm going to continue that. So more than 1 square to the right, more than 1 square to the right, and over here more than 1 square to the right. Alright, this one would be off the graph, so I'm not going to worry about it. So these purple points are extending my graph as far as I can fit. So I'm just going to go ahead and use the extension. Okay, and there it is. That's as much as will fit. And I will stop the video there here at the end of number 8. We have more examples to come. All right, if you'd like to see more practice, actually we have one more of these. Problem number 9 on the next video.